Okay, I'm recording a video for the partitioning handout that we did in class. We didn't get a chance to go over all of it in every class, so I'm going to go through this whole worksheet. This first part, if you didn't get it, if you were absent, you can go ahead and pause the video and fill this in. But it's just talking about what partitioning means. It's a divider. And the second part is the partitioning ratio. So if you have a 1-to-1 ratio, it means that there are going to be two parts. There's one part, and the parts are really segments. So one segment before the partition point, one segment of congruent length, equal length after the segment point. And so a 1-to-1 ratio means we want one part on either side of our partition point, so this would be our dividing point. 2-to-3 ratio means we're going to divide it here so that there are two parts to the left of it and three parts to the right of it. For a 1-to-4, 1/4 ratio, so a part to whole, would be you have 4 total parts, so this is telling you the total amount of parts, and you only want 1/4 of it. So it's just like saying I'm going 1/4 of the distance somewhere. Well, the distance is A to B, and it's 4 different sections. I'm only going to go one of those sections. That's what it's saying. Same thing with the 2/3. After that section, we have a little bit of intro for the steps. So if you need to see the step-by-step solution, this is how you do it. And to find the change in values from anything, if you're ever trying to find the change between two things, you're just going to subtract the ending point from, or the starting point from the ending point. So you'd be minus A. So I'll go through the examples on that. This is my second time going through this, making these videos. I spent an hour making them and then realized that I had the mute button on, so you couldn't hear any of it. So that was super unfortunate, but we're going to go at round 2 because it's super important that you guys get this for your test. So hopefully people are utilizing the resource. So I'm going to go through and do the examples. You can fast forward through whatever parts you already understand, rewind, slow down, pause. Please use this so that you can understand the concepts. That's why I'm making these videos. So A is at 1,4 and B is at 6, -1. We want to find the coordinates that partition the segment. So we want this segment cut into 2 parts to 3 parts. So we want it into a total of 5 parts for our ratio. So we're going to divide this into 5 seemingly equal parts. We call them congruent. That's our word for equal. Congruent. We learned about that in another packet. So if A is at 1,4 and B is at 6, -1, our process is to basically figure out for each coordinate. So we have x coordinates, we have y coordinates. For the x coordinate, how many units does it travel totally for the whole section? And then if we want to cut that into 5 parts, we want to know how much does it have to travel each part. Luckily, the number of parts and points in this case, if it travels a new point, it's going to travel 1 part. So if we do x first, x is traveling from 1 to 6. To figure out that distance, we would do B's coordinate minus A's coordinate. So it's a little counterintuitive. You actually do the coordinate that you want to end at minus the coordinate that you started at. So 6 minus 1 here is how many units it travels, and this is going to tell us, this number is going to tell us how many parts that we're dividing by. So we're dividing that into 5 parts. So that means that there's going to be 5 units that we're traveling for the 5 parts. So that means we need to travel 1 unit for every new point or every part. Okay. So for the x, we're going to be traveling 1 unit every time. So I'm going to draw my brackets here. If I start at 1 and I increase 1 unit every time, I'm going to land at 2, increase 1 unit, 3, increase 1 unit, increase 1 unit, and increase 1 unit. So I land at 6. If I do y the same way, I'm going to do it off to this side over here just because I'm out of space. So y, I want to figure out from A to B what happens. So I'm going to actually subtract A from B. So B minus A is going to give me -1 minus 4. And then I'm again dividing that into 5 parts. So -1 minus 4 is -5 over 5 is going to be -1 unit every point or part. So I'm dropping 1 this time. So I'm starting at 4, decreasing 1 unit, decreasing 1 unit, decreasing 1 unit, and decreasing 1 unit. If I decrease 1 more time, I should land at -1, which I do. And I'm looking for the point, I should have highlighted this first, that partitions this into a 2-to-3 ratio. So I want 2 parts before the point, that's my answer, and 3 parts after it. So this would be my point that divides it into 2 congruent sections before, 3 congruent sections after. So my answer is 3, 2. I'm so bummed that the other one it was just much more thorough, but it's 3 o'clock now and I'm pretty tired, so I'm going to go a little quicker on this than I did on the previous 2. Okay, A and B are given. Find the coordinates at the point that partitions this one into a 1:3 ratio. So 1 part before the point that partitions, 3 parts after, so a total of 4 parts. So we have from 2, 4 to 10, 0. For the X, we're traveling from A to B. We have to do B minus A to figure out the distance between them. So 10 minus 2, and then we're dividing that into 4 parts. So we're going to be getting 8 over 4, or 2. So we're going to be traveling 2 units every point or part. And I'll put point here just so that you know it's either one. Okay, so if I have 2 is where I'm starting from, I'm increasing 2 every time. 2 plus 2 is going to give me 4. 4 plus 2 is going to give me 6. 6 plus 2, 8. 8 plus 2, 10. Then I need to do the same thing for Y. So B's Y coordinate is 0, A's Y coordinate is 4, 0 minus 4, and I'm going to break that into 4 parts. So I get negative 4 over 4, which is negative 1 unit per point. So I'm going to be dropping 1 unit every point that I go over. So starting at 4, if I subtract 1, I get 3. Subtract 1, 2. Subtract 1, 1. Subtract 1, 0. So I know I did it correctly because I ended at 10, 0. So I want the point now that partitions this into a 1:3 ratio. So I want 1 point before the point of partition and 3 points after the point of partition. So it's going to be this point 4, 3. Okay, so go ahead and set the other next ones up, the ones that you haven't done already. If you haven't already set them up, go ahead and set them up. I'm going to set mine up really quickly, just drawing the points and putting them on here. Well, maybe I'm not going to do it that way. Okay, I'll just do one at a time. That way you can scroll easily to where you need to go. So 1, 5, and 5, negative 3. We wanted to partition it into a 1:3 ratio, so a total of 4 parts. Okay, so we want 1 part before the point of partition, or the dividing point, 3 parts after the dividing point. So P is going to be this point. Okay, so we're looking to see in the X direction, B minus A is going to tell us how many units from 1 to 5 is. So 5 minus 1 is going to be 4 units, and we're dividing that into a total of 4 parts. So that means we're going to be increasing 1 unit per point that we go over. So every point that we go over, we're going to increase 1 unit. So 1 plus 1 is going to give us 2, plus 1 is going to give us 3, plus 1 is going to land us at 5. So we did it correctly. For Y, if we do B minus A, that'll tell us the shift from A to B. So negative 3 minus 5, and then we're dividing that into 4 parts. Okay, so negative 2, so we're dropping 2 units every point. So we start at 5, dropping 2 units, dropping 2 units, dropping 2 units, dropping 2 units, we land at negative 3. So point P is the one where the colors changed. So 2, 3. Okay, for number 4, A has the coordinates of negative 2, 0. B is 9, 3. Find the coordinates of P that partitions it into a 2:1 ratio. So 2 parts before, 1 part after, for a total of 3 parts. Point P. We want point P to have 2 before and 1 after, so we want 2 before and 1 after. And that point's going to be P, where the colors divide. Okay, so if we do our X and go from A to B, we subtract A from B and get 9 minus negative 2 over, and there are a total of 3 parts, so we're dividing this by 3. So this one's going to be 11/3 is our shift for each time. Okay, in order to add fractions, so normally we would be adding our shift, but in order to add fractions, we need a common denominator. So what we really want to do is we want to have negative 2, and we want to add 11/3 to that to get this shift, and then we'd add it again and add it again. Well, in order to add fractions again, we need that common denominator. So we need to convert negative 2 over 1 is what this is understood to be, to a denominator where this is 3. So we need it to be 3 in the denominator, so that means we need to multiply by a 3 to get that to be a 3, so we need to multiply the numerator by a 3. If we multiply by 3 over 3, we're really multiplying by 1, so we're not actually changing the value of negative 2, we're just changing the way that it's written. So negative 2 times 3 is negative 6. So if you weren't sure, you want to check, you would just do negative 6 divided by 3 and make sure that it gives you the negative 2 that you originally wanted to start with. So another way to write negative 2 would be to write negative 6/3. That's convenient for us adding 11/3, because now to add 11/3 to this, if we start at negative 6/3, we have the common denominator, so we're really only adding the numerators. So negative 6 plus 11 is going to give us 5/3. Adding 11 to 5 is going to give us 16/3. Adding 11 to 16 is going to give us 27/3, which is equivalent to 9. So that's the check. Okay. For y, we go from 0 to 3, so we want to do 3 minus 0 and divide it into 3 parts. So we're actually only increasing 1 unit every time. So this part we can just do without having any extra. So 0 plus 1 is going to give us 1, plus 1 is going to give us 2, plus 1 is going to give us 3. And our answer is the color change, so 16/3, comma 2. Okay, point A has point coordinates of negative 3, negative 2, and point B 7, 3. Find the coordinates of P that are 1/3 of the distance from A to B. So they're telling us the total distance from A to B is in thirds. So 3 parts. We want to know what point P is if it's only 1 of the thirds away. Okay, so we're going to take our x, which is the distance between A and B, and we do B minus A to get the distance between A and B. So we start with 7 and minus a negative 3, and we're dividing that into 3 parts. So we have 10 over 3 is our shift. So we need to convert this to a fraction. In order to do that, we multiply the denominator that we want, 3, times the integer that we have to get the new numerator. So negative 9 is our new numerator. And we put it over the 3 because that's the number that we already are going to be, that's our denominator that we want to match. And then we add 10/3 to it every time. Okay. So if I do this one, I have negative 9/3 and I want to add 10/3. I'm really only adding negative 9 plus 10 to get 1, and I have the same denominator. So it's going to be 1/3. Adding another 10/3, I keep the denominator, so I'm really adding 10 to 1. And then adding another 10, I get 21/3, which is 7, so that's correct. Okay, for y, we do the same thing. We figure out how many units did it travel from negative 2 to 3 by subtracting 3 minus negative 2. So we have 5 units divided into 3 parts. So we need this denominator to be 3, so we multiply the denominator that we want times the whole integer. Well, it's an integer, so 3 times negative 2 is going to be negative 6/3. That's an equivalent way to write negative 2, so that we can add 5/3 a little easier. Adding 5/3, so we have negative 6/3. If we add 5/3, we're going to get negative 1/3. Now we can continue to add 5. So we get 4/3. Adding 5 would give us 9/3, which is equivalent to 3, so we did it correctly. So P is at 1/3, negative 1/3. All right, then number 6, the map shows a straight highway between two towns. Highway planners want to build 2 new rest stops between the towns so that the 2 rest stops divide the highway into 3 equal parts. So they're telling us the total amount of parts is 3. Find the coordinates of the point at which the rest stops should be built. So we're still going to set it up the way that we did, even though this one's a diagonal line. We can still draw it horizontally and solve. So we'll call Ashton A and Bedford B. And we're going to identify the coordinates. So Ashton's at -3, -2. Bedford's at 3, 3. And we want to divide this into 2/3. Okay. So we take the total distance between A and B's points. So X is shift. If we do B minus A, that tells us from A to get to B, how many units do we have to go. So 3 minus a -3 over, and we're breaking that into 3 parts. 6 divided by 3 is going to give us 2, so we're increasing 2 every time. -3 plus 2 is going to give us -1, plus 2 is 1, plus 2 is 3, so we landed at the right spot. For Y, 3, which is B's Y coordinate, minus -2, which is A's Y coordinate, divided by 3 parts. So we have that fraction again, 5/3. If the fraction was one that divides evenly, like if it had just given us 1.6, we can just add decimals. But if it continues forever, you do need to stick with the fraction answers. So in this case, we need to stick with the fraction answers. And we have 3 here, so we want to multiply it by the 2, the -2, to get the new numerator. So -6 is the new numerator, and 3 is the denominator that we want to be adding. So that's the denominator we put underneath the 6. Checking that, -6 divided by 3 does equal -2, so those are equivalent numbers, and I can add 5/3 now. So we did this actually in this previous problem, but we're going to be adding 5/3, so -6 plus 5 is going to give us -1/3, plus another 5 is going to give us 4/3, plus another 5 is going to give us 9/3, which is equivalent to 3. So these would be our 2 answers for the 2 new rest stop locations on our graph. Okay, just the back left. Okay, given the points, find the coordinate of Q that partitions the segment into 2:3 ratio. So we have points M and T, and we're looking for Q so that MT is divided into a 2:3 ratio. So 2 plus 3 is going to give us 5 parts. And we want 2 before and 3 after, so Q is going to be here. So remember, that first number is how many points are to the left of the partition point. That second number is how many points are to the right of the partition point. Okay, for X, we go from -3 to 5, so we're going to do T minus M to figure out that distance. It's 5 minus -3, and we're dividing it into 5 parts. Okay, so 8/5. Okay, so another fraction. So what we want to do is convert this to a fraction, the -3. So to do that, we multiply the 5 times the -3. That gives us -15 over, and the denominator that we want is 5. So now we're going to be adding 8/5 every single time. So -15 plus 8 is -7. -7 plus 8 is 1. 1 plus 8 is 9. 9 plus 8 is 17. 17 plus 8 is 25, which is equivalent to 5. So we did that right. Okay, for Y, we go from -4 to 0, so we subtract -4 from 0 and divide that into 5 parts. So it's T minus M, and we do 4/5, so we're increasing 4/5. So again, we want to times this by our integer, so we get -20 if we do 5 times -4, and then our denominator that we want to keep consistent is 5, so we're adding 4 every time. So -20 plus 4 is -16, and then we still have over 5. -16 plus 4 is -12, plus 4 is negative 8, plus 4 is negative 4, plus 4 is 0. 0 divided by anything is 0, so we did it correctly. So our answer for Q would be 1/5, comma, negative 12/5. Pause it, rewind it, do whatever you need to do to make sure you understand the concepts for the fractions. Okay, given A and B. So if you've done a couple of these with me or gone through this video kind of step by step, I want you to try this one on your own by pausing the video and then come back and just check to make sure you did it correctly after that. Okay, 4 parts, 1 part before, 3 parts after. And we have, from negative 1 to 7 is an increase of 8 units, so B minus A is 8. And then we're dividing it into 4 parts. Yay, no fractions. So negative 1 increasing 2 every time. So adding 2, we get 1, adding 2, 3, adding 2, 5, adding 2, 7. Good. Okay, Y. 2 to 14, so 14 minus 2 over 4 parts. It's going to give us 12 over 4. Yes. Okay, so adding 3 every time. That's our shift. So 2, starting at 2, we're adding 3, adding 3, adding 3, and adding 3, and we get to that number. So 1, 5 would be our answer for 2. Okay, so next one is a little bit different. So these 3 and 4 are a little bit different because they give you the ratio in whatever form they want, really, but they tell you right before that what that ratio corresponds to. So A, B, and C are collinear on segment AC, so that's telling us those are the endpoints. A to B is 3 parts. B to C is 4 parts. So what they're saying here is B is slightly closer to A. There's 3 segments between A and B, and then there are 4 segments between B and C. Okay, so that's our setup. So again, this AB corresponds to this number, so there are 3 parts between A and B's points. This corresponds to the 4, so there are 4 parts between those points. Hello. I'm doing well. Okay. Staying so late, the cleaning lady's already here. Okay, so 3/4. So this is going to be, A was at 310. B is at 6/4. So unlike all the other problems where I give you the end, this time I give you a partition point, a divider point, and the beginning. So what we want to do is still figure out, we want to treat this B as if it's the end. So we want to do our partitioning process, but with only 3 parts. So we're going to treat it like it's got 3 parts, and then we just can continue the shift on past B. So if we do X from A to B, so we subtract B minus A, we do B minus A. 6 minus 3 is going to tell us there are 3 parts between those, 3 units between those and 3 parts. So we're dividing 3 by 3, and we're going to be increasing just 1 unit every time. Okay, so we start at 3 and we increase 1 unit. So 4. Increase 1 unit 5, increase 1 unit 6. So we got B down here. Increase 1 unit 7, increase 1 unit 8, 9, 10. Okay, for Y, same thing. We want to figure out from 10 to 4 what happens. So we do 4 minus 10. You do the opposite way to figure out the actual decrease, increase. And we're dividing into 3 parts. So it's going to be negative 6 over 3, which is 2 units down every time. So we're starting at 10 and we're decreasing 2, decreasing 2, decreasing 2, decreasing 2, decreasing 2, decreasing 2, decreasing 2. So then our point for C would be 10, negative 4. Okay, I got 6 minutes to try to do 4 problems. Let's see if we can do that. Okay, M, it tells us the segments MS. So points MH and S are collinear, so on the same line for segment MS. MH is 1 part, and MS, the whole segment, is only 2 parts. So I can do the whole segment first. Since it's only 2 parts, I can write those 2 parts. and then MH should be just one of those two parts, which it is. So M is located at 7, -3, and S is at the origin. So when you have a partition of 2 points, you're really just doing the midpoint. So you can do midpoint here instead of doing partitioning points if that makes more sense to you. But this is the partitioning handout, so I'm going to practice using partition. So I'm going to take my X shift, and it's from 7 to 0, so I'm going to do S minus M, and get -7 over just 2 parts. So I want to convert this to a fraction, so I times the denominator that I want by the numerator, so 14 halves. And then I'm going to be subtracting 7 halves every time. So 14 minus 7 is going to give me 7 halves. So for y, S minus M is going to be 0 minus -3. Dividing that into 2 parts is going to be 3 over 2. But this time I'm going to be increasing because I don't have a negative. So -3, if I convert that to a fraction, 2 times -3 is going to give me -6 over 2. Adding 3 halves is going to be -3 halves. Okay, 3 more left. Go ahead and draw this one out. Back to the regular type. Find the coordinates and partition it into a 3 to 2 ratio. So 3 parts plus 2 parts is 5 parts. Okay. So for x, if we want a to b, we subtract a from b. So -4 minus 2, those are my x coordinates. Dividing that by 5 parts. -6 divided by 5. Back to fractions. So 5 times 2 is going to give me 10. So 2 is really 10/5, and I can add -6 or drop 6. So 10 minus 6 is going to give me 4, and I have over 5. 4 minus 6 is -2 over 5. -2 minus 6, -8 over 5. -8 minus 6, -14 over 5. -14 minus 6, -20 over 5, which is equivalent to -4. That's correct. B minus A. So 10 minus 4 are my y coordinates. Dividing that by 5 parts, 6/5. Man, another fraction. Okay, sorry, there are so many fractions on here. It's good practice. Okay, so 6/5. So I'm going to convert this to a fraction. So 5, which is the denominator that I want, times 4 is going to give me 20/5. That's an equivalent way to write 4. Adding 6/5, I get 26/5. Adding 6, I get 32/5. Sorry, I wrote so small. 38/5. Adding 6, 44/5. Oh, I gotta plug in. Okay. 44 plus 6, 50/5, which is equivalent to 10. So I did it correctly. Oh, I never highlighted. So I want 3 parts to 2 parts. So my answer is going to be this point, which is where the colors change. That's P. -8/5, 38. Okay, go ahead and try the next one, setting it up. I am looking to see. Okay, these next two, they don't have any fractions because I'm almost at 30 minutes for this video, and I'm just afraid that it won't upload if it's too long. And that you won't watch it. Okay, so A and B. Keep emailing me. Okay, so A and B, -2. Okay, so we have this. And find the point P that partitions it into a 1 to 2 ratio. So 1 part and 2 parts is going to be 3 parts. And P is going to be closer to A because it's 2 parts. 1 part before P and 2 parts after. So we have, for the x direction, we go from 7 to -2, or -2 to 7, so we do 7 minus -2, divided into 3, so that's 9 divided by 3, whole number, bam, yes. Okay, y, we go -2 minus 4, divided into 3, -6, yes. Okay, so it's -2 plus 3 is 1, plus another 3 is 4, plus another 3 is 7. So we got to 7. We're going to be dropping 2 from this, so dropping 4 minus 2, 2, minus 2, 0, minus 2. Okay, good. So our answer would be 1, 2. Okay, Cleve's Cookie Store is located at the corner of 2nd and 9th, so 2, 9. That's a fancy way of writing the ordered pair. Dave's Doorknob is located at 12th and 14th, so 12, 14. Located 1/5 of the distance from Cleve's Cookie Store is the post office. Where's the post office? So it's basically 1/5 of the way from, I'll call Cleve's Cookie Store C and Dave's Doorknobs D. Then it's 1/5 of the distance. This is telling us this is the total. Okay, so 1 out of 5 sections. So we want to go 1, 2, 3, and we want to look for this point. Okay, so x, we go from 2 to 12, so 12 minus 2, and then dividing that into 5 parts is 10 divided by 5, which is 2. So we're increasing 2 every time. 2, 4, 6, 8, 10, 12. Good. Y, we're going from 9 to 14, so 14 minus 9 will tell me my shift. And there's 5 parts I'm dividing it into. Increasing 1. 9 to 10 to 11 to 12 to 13. Okay. That's it for the partitioning.